Hi students, we are now going to record video 5.5. The unit title is Polygons and Quadrilaterals, and the objective today is, again, I can prove quads are rectangles, squares, rhombi, and our focus today is on trapezoids by using their properties. After today, you should be able to do IXL skill number N or letter N6, so good luck with that. And please make sure you read the comic here, because there will be maybe a answer on the quiz related to it later this week. All right, so our first definition is going to be on a trapezoid. Well, a trapezoid is a quadrilateral with exactly one pair of parallel sides. Okay, so here's our trapezoid. We see that we here have one pair of parallel sides here and these other sides are obviously not parallel. Another thing important to note about trapezoids is they have bases and they have legs. I know you heard those words before in triangles, but trapezoids have the same thing. So a base is here, and these are actually legs of the triangle. So as we see, the bases here are parallel, but the legs are not. Next, we have an isosceles trapezoid. Now, isosceles trapezoid is simply a trapezoid with congruent legs. So we can add in the markings here and here to show these legs are congruent. And if these legs are congruent, that's going to force these angles opposite the legs to also be congruent. So these are indicating that you have an isosceles trapezoid with legs congruent and base angles are also congruent. So if we have the base angles congruent, again, we do have an isosceles trapezoid. So now we want to look at the diagonals of an isosceles trapezoid. So here's an isosceles trapezoid. Where our legs are going to be congruent and our base angles again are congruent. And if we draw on the diagonals, let's make them blue, from non-adjacent to non-adjacent, these diagonals that I've just drawn in are going to be congruent. So those complete lines here are going to be congruent lines. A trapezoid is really cool also because it has a mid-segment. So if we construct a trapezoid, and we're going to use a trapezoid that is not an isosceles trapezoid. So the mid-segment is going to simply be the segment that's joining the midpoint of the leg. So here A is the midpoint of the leg, and B is the midpoint of this other leg. So this is our mid-segment. So the mid-segment has some really cool properties. The first property that's really cool is that the mid-segment is going to be parallel to the bases. Okay, so it's parallel to both bases. So that would make the mid-segment here, AB, parallel to this segment here and this segment here. The other really cool thing about the mid-segment is that it is equal to 1/2 the sum of the bases. So if we were to find, say, this length of this base and say it was 5, and the length of this base was 17, then we would actually take the sum of these two, 5 plus 17, then we divide by 2, and we get 22 over 2, which is 11. So that would be the actual length of this mid-segment, 11. So let's look at example 1. Example 1 says CDF is an isosceles trapezoid and MC equals 65. What are the measures of angle D, E, and F? So the measure of angle F is the same measure of angle C, because this is an isosceles trapezoid and base angles are going to be congruent. Got tongue-tied right there. Now, because an isosceles trapezoid or any trapezoid is a quadrilateral, it still means that these two same side interior angles, they're going to be consecutive and they're going to add up to 180. So 65 plus some number is going to give us 180. Both angle D and E are going to be 115 degrees. Let's take a look at number 2. Segment HK is the mid-segment of trapezoid LMNP. What is the length of MN? So we know that both of these bases, okay, and that will be 3x minus 8 and x plus 1. If we add them together and divide by 2, we'd get the mid-segment, which here is shown to be 18.5. If we keep going and simplify it one more step to 2x minus 9 equals 18.5. And then again, we're going to divide by 2, just keeping through the algebra here. We end up with x equals 23 after we cross multiply. Now we want to go ahead and substitute that back into the problem, which said, what is mn? And that's going to be 23 plus 1, which turns out to be 24. The trick with this problem is recognizing that the bases are actually here on these sides, okay? And remembering that the bases are going to be parallel, always parallel. And here is a secret hot question that says, what is the measure of angle DCA in this isosceles trapezoid? Thank you very much. See you tomorrow.